Welcome to Ask and Learn.
Hello and welcome. We are looking at Chapter 5, Section 4, Problem 18. We're asked to prove Algorithm 1. Um, so let's real quick just copy down Algorithm 1 so we know what we're proving. So it's a procedure called factorial. Takes a non-negative integer n, um, oops, if n equals 0, then we return 1, else we return n times factorial of n minus 1. So we want to prove this, and we're going to use induction to prove it. So with induction, there's two steps. There's the base case, basically proving this first step here. So we want to show that, let's write that in black actually. We want to show that factorial 0 equals 0 factorial. So factorial 0, by definition, if n is 0, then the result is 1. And it's a well-known fact that 0 factorial is 1 as well. So um, the base case is proven. And so with induction, next we want to show that we set up our dominoes and we want to show that if you knock over one domino, the rest of them fall. So we want to prove the following statement. We want to prove if factorial n equals n factorial, then factorial n plus 1 equals n plus 1 factorial. And you could also solve this replacing this left-hand side with n minus 1 and n minus 1 factorial, and this right-hand side with n and n factorial. Might be easier, I don't know. So with what we're doing, we start with the if part of this. This we get to take for granted, and we want to use true mathematical steps, logical steps to get to the then side. That's how you prove by induction. So we want to start with just stating the fact that we take for granted. Factorial n equals n factorial. Then we need to think about how can we take this and get to here. So I look at the right-hand side because that's easier for me to think about manipulating. N factorial is not that different than n plus 1 factorial. N plus 1 factorial is the same as n plus 1 times n factorial. So I have an equation here. So if I multiply both sides of my equation by n plus 1, so let me kind of make this more into a narrative. If this equation is true, then n plus 1 times factorial n equals n plus 1 times n factorial. So this right-hand side, so we can say then clearly this right-hand side is n plus 1 factorial. So I'm kind of switching the right-hand side and the left-hand side, but that doesn't matter. Equals n plus 1 times factorial n. So why don't we want to show that this right-hand side here is the same as factorial n plus 1. So why don't we start with factorial n plus 1 and kind of work backwards. So we can say we know factorial n plus 1 equals, and then we can use the definition that we started with up here. So if n equals 0, then 1, so we have to say we know for n greater than 1, for n greater than 0, I should say, for n greater than 0, that factorial of n plus 1 has to be n times factorial of n minus 1. So if we take whatever's inside here and subtract 1, then we get n plus 1 times factorial of n. And then we can say as wanted, because we've proven it at this point. So we've shown that this right here is equal to this. And that is exactly the right-hand side here that I wanted to prove. Oops, crossed it out a little bit there. All right, so our proof is done.